Need to stop the music?
Oh yeah, probably.
Let's go.
Hey guys. Well, maybe it's just. Oh, there it goes again.
The play button. It's a problem.
I'll be right back. All right. Hey guys, how's it going? Uh, it's Friday. We haven't done this for a while. Forgot some things. Spent a little time organizing the studio, and then came in today and just had to start over. I'm Aaron, by the way. How's it going? Thanks for joining us. With me today in the studio is Jody.
Hi, I'm not Matt, who apparently knows what he's doing, whereas
Where's the adventure if you already know how to do it all? Boring. Man. Yeah, it's Friday. It's Friday afternoon, and we're hanging out here in the Sketchup HQ studio. Gonna do some modeling, some live modeling. It's gonna be fun. We've done these, so we're gonna model some machine parts. That's what we call these sessions. And what this really is we go online and we get pictures that are usually, they're made for practicing drawing in CAD. So taking these images of solids from maybe 2 or 3 different axes, views, and using those exact dimensions to create something in 3D. So that's exactly what we're going to do. I posted, if you look in the description, there's a link to our forum, forums.sketchup.com, and there's a link to 4 or 5 drawings that we're going to be using today. Oh, words. Rough stuff. But yeah, so if you want to grab those files, you can follow along. If you just want to watch, that's cool too. The goal with this is generally to just use native tools and just draw the things. It's a great way to practice modeling in 3D. And we found a lot of people who've gotten a lot better just using the tools to make that. I do want to mention one thing because we had some people call out that our modeling that we did was not accurate enough. That we didn't do something that could actually be CNC'd. It wasn't accurate enough. It wasn't good enough. I don't really have a response other than really this is to practice modeling in SketchUp is the goal here. None of these are going to actually go to a machine. But yeah, if you do have a situation where you're modeling for machining, I guess pay attention to accuracy more than I do. I don't know.
well, it's worth saying everybody can do this. These files or these drawings are available. So
That's right.
if you want a more technically accurate one, you have the power to do it.
I love being one-upped. Let's do it. Speaking of one-upping, we have at least 2 people who are watching right now who have already started modeling or finished modeling these drawings. So I waited till like 4 hours ago to post the images. Uh-oh, you covered me up. Yeah. See? Working out bugs.
Didn't realize I can do that. I'm gonna have to stare over to the left.
That's right. You turn your head. I'm sorry. I'll try to fix that next time. All right. Well, with that, let's hop in and let's start. I do want to say hi to everybody. I mean, we have a ton of people on already saying hi. I apologize. Sometimes I get so excited to model. Hey, thanks for coming.
How you doing?
Yeah. That's good to see you guys. It's awesome. We did take last week off. We just kind of did. We just didn't come in. So, but this time we figured we'd get back and we would do something we've been doing for a while. We haven't actually done a machine parts it's been a long time. I mean, it's been months, something like that. We were doing them like, once a week or something like that for a while? There's a lot of drawings of small machine parts out there. So if this is a thing that you see and you're like, ooh, that's cool, there's plenty of content. You can get this.
I feel like there's entire pin boards on Pinterest that are just these drawings.
I just typed in machine part drawing and get one and then click the show me like drawings and just for days. So different varying levels of value in these drawings. So some of them are great, some of them are really well dimensioned, some of them make you work a little harder for it. So I think we got a little bit of a mix of both this time. So with that, let's hop in. Let's do this thing. All right, so here we are in SketchUp. First thing I'm going to do is I am going to go to my model info and change my units. So I'm going to change from units to decimal, and I'm going to change from inches to meters. So I'm going to, the drawings themselves are going to be in millimeters. So that's pretty standard for something that gets machined. I'm going to model everything in meters with the millimeters value, so that way I don't run into the small face issue inside of SketchUp. Just to let everybody know, so SketchUp was created based on the thought that it would be used for architectural, so it was never created to work with create very small faces very well. So by bumping it up to meters from millimeters, we're going to use the same dimensions that we see on the page, but it's going to model it, what's that, 100 times bigger, 1,000 times bigger? I don't know.
Why not both?
We could rescale it down.
1,000 times bigger.
Oh, how about that?
That'll break things in a different direction.
Too big. So that's what we're going to do. We're going to work with it like that.
Dave wants to know if he's got permission to show what he's already done.
Of course, Dave. Post away. Yeah, go for it. I think somebody else, Andy was also starting to post some stuff too. He was running into some missing dimensions, which I thought was exciting. I haven't looked at the drawings that much, so I don't know what we have and what we don't have.
I'm looking at these drawings and I can't help but think part number 4 is basically just the SketchUp logo.
Isn't that funny? Yeah, so we're gonna start with this one. This one is part number 1. There is no significance to these numbers, these values. I just put some names on them in the order I thought they would be good to, like this would be a good warm up and we'd work our way up. That's everything that's going on here, so don't look for any more meaning than that. Okay, so here we have it. This is the thing. I imported this as an image. I threw it on the ground. I did not scale it. I'm not looking to actually trace and draw these things to scale. The whole point of the practice that we're doing right now is to use these dimensions to make these drawings. So I'm intentionally, this is probably not to scale. This is probably not 54 meters. Let's see. No, it's 1.4. Ooh, this is me a little too big.
Dave and Andy both said they can barely hear me. I don't know if I turned my face away, but if there's knobs for me to turn them in.
Yeah, turn that number, the one with the green cable.
Yep.
Turn that one to the right some more.
11? Is 11 okay?
So let's see how it goes.
All right.
You might just have to get up on it and get more friendly with it.
Come on up in here.
Because somebody was using it right. All right, we're gonna hop in here and start drawing this thing.
As I'm looking at this, I'm thinking this would actually be a great way for people if you happen to be in the beta for the iPad version. This would be a great way to start practicing your iPad version of SketchUp.
Absolutely. I'm gonna actually switch this over to millimeters and try to model it and see what happens. See if we're closer this way.
Learning opportunity.
So it's gonna be way smaller now. Where's 54 at? Oh, geez. 54 is gonna be teeny. Oh boy. Just have to really, really get on there.
Typing a lot.
All right. So, yeah, I'm trying to figure out how, I guess we'd bring this back down to a more realistic size, and then we'll try to draw on top of that. We'll play with dimensions as we go through here, and if we need to make changes, we'll make changes. All right, so right here, I'm going to start by drawing the footprint of this piece, and then we'll come up. So this piece is, what's the overall width of this right here? This would be the one dimension I don't have, right? Okay, but we have this. Am I just not seeing it? All right, so I know that this dimension right here is 54.1. So that's the first piece. That's this line right here. Then we go up. Oh, here we go. Here's a radius of 31. Is this a radius? No, it's a diameter. So it's 31.8. That'll get us our original 31 or initial rectangle. And I know I didn't use the rectangle tool. I think it's because my brain accepts those dimensions one piece at a time that it's easier for me to do it that way, but I don't know. I know some people want to know why I don't use the rectangle tool right off. It's just habit, I guess. All right, I'm gonna draw a circle. I'm gonna use 24 sides for all of my circles. And I'm gonna start at the center of this line. pull up to here.
That was a different center.
Yeah, that first one was not right. There we go. All right, so then I have that. Now I'm going to put this, since this hole goes all the way through, I'm going to put this as part of my footprint. I'm going to come in here with a circle, grab the middle. I'm going to pull that out the same direction on the red axis. See, I'm going the same direction as I pulled out. Well, actually, the first one I pulled out green. It'll be the same. And that is...
See that it's posted. It just shows you the thickness of the wall.
So right here, 19.1 is it? So,
Oh, yeah.
and here's our math shortcut for those who are like me. I can type 19.1 halves. No, wait, that won't work. I'm gonna have to do math.
Yeah, that was one of the first things Dave said was there's going to be lots of math in today.
Dang it. How can I cheat this? Hold on. No, I can't. Okay, here's what I'm gonna do. I'm gonna draw a line right here that is 19.1. I'm gonna grab that line. I'm gonna move it middle point to a middle point and then draw a circle up. So those of you who are better at mathing probably could have done that math quicker. For me, drawing a line and moving it was quicker.
That was an excellent example of how to use inferencing to accomplish something in SketchUp.
Yes, inferencing mathed. All right, I'm gonna pull that up right here, 6.4, 6.4. And then this circle goes up 12.7. So I'm gonna, a couple ways I could do this. I could come in with a circle. I could go to the middle point right here. I could pull that up.
You forgot to turn on your screen, your keylogger.
Oh, nuts. Let's see if I can, shortcut key sometimes works. There we go.
Boom.
So that would be an option. The other thing I could do is I could grab this arc and I could inference to the center here and option copy that around 180 degrees. That works as well. All right, then that needs to go up. More mathing here. I'm just going to draw a line. I'm going to come over here like this. Maybe this is my goal today, is to not do any math. 12.7, and then I can just inference that up to that point, and then option smooth that line. That gets me this piece. So now I have this. This part right here is going to come up, and I can use this right here. This is a good spot to see that. So this comes up to the center of the circle is 25.4. So I'm going to start right here. 25.4. That's the height. The thickness is right here, 9.53. So I'm just going to grab this line right here and move it. Option 9.53. That's, of course, the Mac shortcut for copy. On Windows, it would be Control. All right, and now I need to put a half circle on here. I do have the radius written, but it really should just be this right here. So that's what it is. I'll take that, pull that straight across like that, and we can get rid of that line.
So Bill points out that if you're modeling it 10 times, and you wouldn't have to worry about that decimal. Right?
Yeah, but I would screw that up.
Sometimes it wouldn't be.
No question about it. I'd be redoing dimensions constantly because I would forget. So yeah, doing one-to-one, not gonna worry about it. All right, so I'm gonna come over here, and this is nice enough to have a radius, so I can just type in this 15.9. Oh, that's the outer.
Oops.
Son of a gun. I don't know that that's, oh, right here. 19.1. Sounds familiar.
Deja vu.
All over again. Here, just undo it. Wonder if I can get tricky right here. Let's do this. This would be fun. I'm going to copy this. Rotate it. Grab it by the center. Move that center to this center. And then pull that out.
All inferencing all the time.
Boom, like there's no tomorrow. 11.2. Didn't even have to draw anything for that one.
is sort of like a Lego kit. You just kind of grab pieces and stick them together.
That's right. Less thinking, more doing. That's how I like to. That's my precision modeling tactic. Just don't think so much. All right, we have a little hole right here. So there's this 22 by 7.9 opening. So let's do this. Let's take this line 6.3 up. So I'm going to grab this option, move that vertically, 6.3, enter, and then it is 7.9 tall. Whoa! Move that up, 7.9, that, and then it is 22.2 wide. So that means if I come to the very center, I'm going this way, 11.1. Sorry, I did that math in my head. I just had to show you that I can do that, especially when it's very even numbers like 2 divided by 2. I can nail that all day long. Oh, that's coming, I'm sure. All right, so I'm going to grab those, and then that pushes in not all the way through, but 8. So grab that, push it in 8, and then delete that line. So work on this piece is coming along. I got a couple holes in here. So there's some holes down here. There's some holes into the circle. We'll do that with solid tools. It's the easiest way. I mean, this hole right here is easy enough to punch through. We could do that one now. This one where I have holes coming in into a rounded surface is definitely going to be easier with solid tools. Using solid tools means getting this to a solid state and making it a group first, and then coming in and putting the holes in. The one thing I'm not 100% sure about right here is this guy. So it looks like he's at the center. He or she, they are at this, I'm not gonna be able to say it. Go pull that up to the middle of this circle. Actually, I guess I could pull it up. Oh, I just pull it up to here. Right wherever this line ends. That's the same height as the center of this, which it looks like is where that's supposed to be. And then see, it has a rotation of 30.6 from the flat. So here's what I will do for that. Actually, I probably wouldn't even do it there. I'd probably go like this. Draw it right here, grab that, rotate it, 30.6. And I'm going to grab that and drop it right here. Now I can just take that line, continue it all the way, just run it right through. All right, there we go. So that is kind of what we're doing. Actually, I'm going to drop that down. Get me a plane right there. All right, so that is not done though, because we do have a 2.5 radius arc right here. So maybe I'll go like this to give myself a work surface there. And then I can draw an arc here to here, then pull it down. How would I do this?
So it's a 5 diameter.
So if I just draw it, then select it, and then come here and say 2 point. It didn't work. 2.5. It didn't like that. Make a copy. 2.5. I will come at you. All right, what? All right, let me put this back. So
Like I would probably make a.
I feel like something's not right.
5mm circle.
Okay.
Just sort of
All right, let's do that.
wedge it in again.
So we'll make that, take that, option, copy it over here. Something like that. Doesn't quite meet up, but it gets us close. So if that was correct, then we could do some erasing. And it would get something like that. Doesn't look right. Dave's probably telling me in the chat why I'm doing this wrong.
No, but Andy did say he had fun with this part.
Okay. Well, hey,
That does not.
I would consider that fun. No, it's not too far off. All right. So the width of this is 6.4. So I'm going to go ahead and grab it here. 3.2. 3.2. And then did that get you? Oh, whoa, here it is. There's a thing. All right. Just when you thought you were just about done, pump the brakes, buddy. So there's two ways this could meet up, obviously. This arc could actually eat into the circle, right? So this could, I have it meeting here at the tip, but it could meet in at the edges, which would give me a little bit more of a swing down here.
And that might be why.
Might be why I feel a little off today. Let's see, what does this look like from the top? Yeah, see, this goes all the way through. So that arc actually goes to right here and not, oh, tricky, 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 tricky. All right, I'm gonna go ahead and go like that. Delete this. I'm gonna make this a group. And I will pull that back to here. And then I will explode it. I made it a group because SketchUp is always going to try to keep geometry connected. So if I moved it without making a group, it would have stretched everything over. By making it a group, I temporarily isolate the geometry and then pull it over. And then I should, let's see.
They said this method would be harder to machine.
Yeah, but some, like I said, commenter who I won't mention already told me I do a bad job at that. So
you're just leaning into your flaws.
I'm gonna do it as wrong as possible. That's right. I'll show you poor quality. No, I'm just kidding.
No, you won't.
That's right. All right, yeah. So that probably would have made more sense to go back and do that a little differently. But hey, we're matching the drawing more or less, so I got that going on. All right. Probably time to save.
Andy said he made the slopey bit a separate group and then unioned it with the main piece.
I have other jobs called machine parts, I'm sure, so threw a date on there. All right, last bit is going to be some holes. These holes, like I said, are simple, right? Because we got a 3.2 in, 10.3 up. So if I go, or I forgot the number they said, 3.2. Not only does he suck at math, he also can't remember a number for 10 seconds. Up 10.3. Actually, I think it has more to do with self-doubt than anything else. I'm worried that I'm mixing up a number. There's a lot of numbers here. All right, so I have an outer diameter of 3.45. So if I didn't want to do math, again, I come here, 3.45, grab that right there. Get rid of these extra lines. And then what I'll do here is I'll pull it not just to here, but I'm going to pull it all the way through like this. See, that gives me a hole through both sides, but it doesn't break the interior wall here. So if I grab this right here, I say intersect face with model, that'll break it right there. I can grab this tube and delete it and then get rid of this and get rid of this. All right, so that's that piece done. These pieces out here, like I said, it's gonna be a little bit more work because I want to take this, make it a group. I know Dave would say make it a component, but I'm obstinate apparently. I don't know. And then I can come in here and I'm just going to draw this on the page right here. 3.45.
Andy pointed out that little notch that plugs into the end beneath the
Mm-hmm.
round peg, it's got rounded corners. You can kind of see it when you're looking from the top down too.
Oh, is that what that is? Oh yeah, look at that. 0.8 radius. All right, we will add that. I'm gonna grab this, make it a group. Rotate it like this. Now, I'm gonna grab it by that center point, very intentional, and I'm gonna line it with there's a center point, and now I'm gonna move it back. All right, so that puts the middle point of this circle in the middle of this circle here. Now I got to drop it down because it is 7.87 off the bottom. So I'll just come over here and 7.87 and move this from, again, the center of the circle vertically to right there. Now they are, so off the center, 90 degrees apart, 45 this way, 45 this way. So I'll take this one and I will, again, off the center, rotate this 45.
Arrow shortcut, super handy there.
Oh, yes. And then this will go this way, option copy, 90 degrees. And there's my two solids to subtract. So now I just go into solid tools, which is probably a tool set I should just keep on because I tend to use it a lot with machine parts. I'll select it and I'm going to subtract from, oops, this guy's not solid for some reason. Let's run solid inspector. I know I'm cheating. I am actually using an extension, but it's a free extension that everybody should have on their machines and it's part of web. So is it really an extension anymore? All right, so take this, subtract that from here, and take this and subtract that from here.
Dave said he did the same process, but he did the drill holes, the drill bits, I guess, made them in place. I wonder how much more frustrating that'd be. Or less. Also, everybody's asking about guidelines.
Yeah, I've heard of those. I've seen them. I've seen them around.
Yeah.
I'm terrible at using guides. I just don't ever use it. I just use geometry. I don't know. There's this thing in my brain that tells me it's an extra step, so I don't do it.
Yeah, because what you did was so efficient with no extra steps.
I think I say that jokingly. Obviously, they're great. They're great tools to have. I just don't ever. No. I don't ever. What's up now? Can't talk and think. There we go. Get that one in, and then I can double click. Double click. Double click. Oop, missed it. And then I can just do a quick push pull to pull that out. Double click, double click, and then some cleanup. A little erasing. And then what I probably would do is just do a triple click to select everything, and then soften and smooth to get rid of any extra lines. And that would be part one. All right. I feel warm. That was 20 minutes. It's a little longer than I wanted it to be, but let's go ahead and scoot you over. You go hang out by Sumele's foot. All right. I'm going to save, and I got to keep blasting through. I want to get to that assembly. The last one I have is an assembly, so I want to make sure that we get to that one. So let's see. Part number 2 is right here. All right, this is the one that Andy was saying he thinks is missing some dimensions. I say he's thinks, I believe it. I'm not saying that you're wrong, Andy, but I think we can work it out if we work together as a team.
Right now, what we're going to do is actually find that missing dimension.
That's right.
Or not find it because it's not there. They said I'm still really hard to hear, so I'm thinking that this microphone must not be.
It is our podcasting mic, so you really have to get up and like actually touch your face to it. It's clean-ish.
I don't know if I believe you.
I don't know. That's
I'll
fair.
try it.
All right, give it a shot. Oh, is the dimension that's missing this one here on the end? I'm trying to find an overall dimension for this. This is a half. So I think my mindset would be to model half of it because all these pieces repeat on both sides. So I'll probably model half of it.
So I think you should be able to use the radius of that outermost curve to figure out the overall length.
Right. So that'll work this one. But what about up
No,
here?
on the other side,
Oh, no.
the other, look to the left. Move your cursor to the left. Yeah, there.
Here. How about that?
You got 3 different marks there. With
Okay.
radiuses.
So hold on. So first I got this line. It's 80, right? Start with 80. That's the first piece. That's right there. I got another one coming down here, 75. And I got another one's 55. So that's these 3 dimensions. This. Why they got to be rude like that? Okay, here we go. 40. So it's a 20. Right? Half of that is 20.
I just want to celebrate the fact that these are all real numbers.
There's no decimal points. How rude was that for a sample drawing? That was not a real thing. Why the hell did I put that? Thanks for pointing that out. Now I'm irritated. This is radius of 20, so another 20. So in theory, this is now the full dimension. So if I go like this and like this dimension, that 250 millimeters, you guys who did this before can tell me if that was right. And see, I did that without doing math. I'm just saying. Got away with it. All right, so I'm going to work off this as the center line. I'm going to see how this works. Because if I come this way, 40. Where's that 40? There we go. And that should come down to, if that comes down to here, that's this line right here. All right, I'm going to run that long like that. And then at this point, this is probably where reference lines would probably be a good idea. Guides.
In the business.
So I'm going to take this line, which is right there. This comes over 55. And then I'm going to put a circle where that is, right there. So what's my outer diameter is 20. So I'm going to go this way, 20, enter. All right, so that gives me that, and then I have a radius of 20 here, which should be, that should just be an arc from, because this is a 20 radius also, that's a 20 radius from here up to here. Awesome. So that gets me all of that. All right, now down here, this guy right here is 40 also, so up 20, that's this line right here. I can just do a circle, pull that down like that. It gets me to that. And then this is where I have a tangent line going from here to here. So true tangents are tricky in SketchUp because you have to use an extension to figure true tangents. So I am totally cutting the corner on this, no pun intended. And that is only part of it. That's not ideal, I admit. But it gets me that piece. So there is a I think it's called true tangent extension that will let you, it'll figure that out for you, but I am not using that. All right. I'm going to, let's put this little riser right here. If I come here, go this way 15, drag that down like that, and then come here, come down 55. I guess I could have drawn that down 55 instead of running it long. I got excited.
Especially since you're so precise with your not wasting steps.
I also should have done that first as well. Do a little clean up here. All right, now this piece right here. So that's, I just pulled that up 20. This to the circle is 60, so that's another 40. Pull that up, 40. Get rid of some lines here.
It's
All right.
part number 2 or part number 4? You jumped ahead. That's okay.
Yeah.
Carry on.
Like I said, those numbers are just the order in which I downloaded them. So, all right, so this is a radius of 20 as well. So I'm going to go ahead and grab a circle. I'm going to put this in the middle and pull it out 20. It doesn't go all the way through. And then I'm going to take it and scoot it over to here because this, maybe this. There we go. I like that better. That is where that is. There we go. Boom. That gives us that leg. Now, what we have here then is, do we have dimensions? 30. Okay, a circle of 30. So I'll go to, grab my circle, go to the center here, pull it over 15. And that comes out 10. So I'll pull that this way, 10. Oh, I got some hidden geometry somewhere. There we go.
Max is curious if there's a reason for your default number of segments.
24 is evenly divisible by 2, 3, 4, and 6. So I'd imagine something like that. I don't know. That's been that way since well before I used SketchUp, so I can't really say what that reason is, but
It's doesn't get too heavy. That's like 60 would get you there as well, right?
right. Yeah, it's a nice light number compared to a lot of times. So when I just model stuff for modeling in SketchUp, I use 24 for that reason specifically because it's real easy to divide. You can draw a clock using it because it's evenly divisible by 12 even. If I'm going to go bigger, like I'm going to 3D print something, I'll usually go to 96. And 96 is also on that evenly divisible range. I don't know what you'd call that, but yeah. I'm going to take a quick break and smooth some things. Oh, yeah. All right, so that gets me to here. I have a couple more pieces, so I'm not going to put the circles in the middle. I'll put the circles in the middle after we join the whole thing together, the two halves. But I'll put this circle in here, and then I'll put this chunk right up here on there, and then we'll join it together, and then I'll come back in and drop my middle circles in. So this one right here we could probably, come here, buddy. Come on, come over here. This is a much better position or view to work from. Look at all my real estate taking advantage of this. Oh no, my head's not even in front of anything. That's weird.
Yeah.
I'll get there. All right, so question now is, okay, so I can inference the center, perfect. So I'll grab a circle right here. Oh, these are countersunk. These circles are, here we go. 10-inch drill, so 10. So go 10. And then it looks like it's telling me to go 5 deep. And then another circle from the center of that, which is 10, which goes all the way through. And speaking of inferencing, I inferred all that. I don't know what these words actually mean. I got a big circle, a smaller circle, one drops down. So that's what I got out of that. So forgive me if I'm incorrect. All right, now we got this thing happening. We're doing this thing. All right, so I'm going to create this original geometry actually not from the outside like it's showing, but I'm going to model it from this side because I have this nice flat face to work off of. So that's what I'm going to do. So this is 55 off of the center point of this arc. So if I come here, come this way, 55, gets me there. Drop a line to reference that. And that point is 35 off of the ground. So down here, go up 35. And they're at that circle. Oh, here we go. 50 outer diameter. Woo.
All out.
Making words up. 25 puts it there. All right, so now this is what I was talking about when I was talking about using a circle with those edges. As long as I draw on the axes, so as I drew that vertical, as long as I'm on the red, green, or blue axes, then I know that I have a point right here that I can drop down, a point right here that I can drop down. Not sure why it's not closing. Let's just force that. And that gives me that face like that, which is what I got right here. Now so that is going to come across. I wonder how that's supposed to, oh no, so it'll go like this. So I'm going to take this out. Actually, I'm just going to run it long right now. We're going to come back and trim that back in a second. From here forward, this comes up to here. See that right there? It goes up high. So just pull that up now. And then let's get this full circle on here. For this side, again, find the center. I'll just pull it straight up. There we go. And I'm just going to, for right now, I'm going to push this back to where it meets there. Push that back as far as it can go. And then we'll also have to pull this back to, I'm running it right through there. That's good stuff. That'll work. All right. So I kind of created a little bit of a mess right here. You see, I got stuff overlapping here. I got these pieces jutting out. A little messy. So we're going to clean that up. I'll start by selecting this, saying Intersect Face with Model. That'll give me a edge right there. Go ahead and clean these guys up too. Actually, I guess I delete that one and just clean up that one. Now this, I'm assuming, if I look at the face here, this face just continues straight through. See that? So what I want to do is I want to have this face come through and cut these chunks off. I'm going to do that by coming right here. Or actually, it doesn't really matter where I go. I can go here, pull a line straight up. Right here, pull a line straight up. And connect those two. And then I'll grab this point. And actually, we'll drop down. There we go. All right. Now, probably could have put that in a group before. Actually, let me do that. Let me do that a different way. Let me right-click, and with nothing selected, I don't do this often enough because it's a newer command. But I'm going to say make a group. That puts me in a brand new group that doesn't exist with anything else. Now I can use this geometry as a reference and draw a plane, a rectangle in the plane, not even rectangle, just a face in the plane of the edge of this part, like that. And that creates that. And because I'm in a group now, that geometry is separate from the main body. So now I can come out here and I can grab, I'll just grab the whole thing. And I'll say Intersect Face with Model. So that'll go in and break everything at this plane. Now I can just come in here and start. Oh, that did not give me what I was expecting. Oh, that's why. Okay, undo. Let's do that one more time. I got to get this piece running through. So take this guy and pull that in over here. Opposite is true. Well, no, same thing though. Take that option, pull that through. There we go. And now I can take this Intersect Face with Model, delete that. And now if I delete this, there we go. There's gonna be a lot of cleanup to do with this when I'm done. It runs all the way through. Same thing here, should be able to hit that one right there, and then just close that face. As soon as I do that, everything goes away. Get rid of these guys, get rid of this line on the top. And I did, obviously, I ran that well long of where it needs to go. That's okay, Because here, I'll see what's that total length.
130?
Oh, come on, man.
60.
65. That's right. I knew that. There we go. And then I can just push that back to that inference point like that. All right. So one of the things that's going to happen, so I could have done that multiple different ways too. I could have actually modeled that circle as a totally separate piece and then run it back in instead of pulling it off of the original geometry. You can actually see how that could have helped a little bit. But one of the things I do want to do now is I want to kind of poke my head inside and clean that up. So maybe I'll actually just select this and temporarily hide that surface. And I can just come in with an eraser.
We'll poke your head inside this very 3D mouse.
It is. That's why. Try not to make that like a requirement. But if you have to stick your head in a lot of your models, then a 3D mouse is a good thing to have. All right. And then we can just go up to Edit, Unhide All, which will give me that face back. All right, last thing on here, I have a hole. Looks like a 15 diameter, so I'm just grabbing another circle, find the center, pull that over 15. All right, I think that's everything now that is not part of the bigger piece, so I'm going to grab this, delete that. Grab all of that, option copied over here. I'm going to scale by -1 around the middle and then bring it back right there. So one of the issues, of course, now is I do have to come in and weld it together by getting rid of the center line. Not a huge deal. Just have to make sure you hide the parts that are seams and erase the pieces that are cuts, like that. All right. Now, we just got a couple more circles to throw in here. Let's put one right here. I was kind of wondering if I was going to lose this. Oh, there it is. Got it. Boom. Like that. All right, and that raises up 45. How far off the ground are we now? 35. I'm not counting that as doing a math because that's simple. 45 minus 35. And I'm actually counting my toes, so you guys can't see that math. All right, so when I did that, I got a broken thing right here. See that? So that's actually telling me when I did that initial circle, these lines broke. And not a big deal. You can always soften that. But if it's geometry you're going to inference again or use again, it might be good to weld it first. So what I'm going to do is I'm going to come in here, double-click the circle, which highlights the edges all the way around, and then just right-click and say Weld Edges. And then when I do that, now I have a full circle. So when I pull that up 10, I don't have to clean it up. Because I welded it though, you'll see that it did break it here. So I do have to come in and just erase those. That's what I mean, that's not a hard and fast, it's not gonna always break in that same spot, but I'd rather do that and have this continuous and have this all clean rather than have to go in and erase that stuff again. All right, so I'm gonna come in here and I'm just gonna use offset this time. Offset that by 5. Should be 10 on either side, or 10 total. And that pushes down 15. All right, and then inside of that, we have a 20. So actually, so I'll just offset another 5. And pull that to the bottom, and that section is done. All right, one last chunk here. All right, so we actually have something that goes off the center line of these two circles. Now, again, because we're using segmented circles, it's real easy to grab the corner and just pull a line like that, which is going to be the middle there. So then I can come in here for this hole right here, just go to the middle, pull that up 25.
Broken.
It drew a face on my circles. Quick cleanup. All right, so this circle right now, because this extends both above and below, I'm going to take it right now and I'm going to Option copy it straight down. So now I have that same circle on both sides. Make sure it's facing the right way. All right, so this will, let's see, where does this go up to? This goes up to the center of this circle. It's like this example was made for inferencing. And then it comes down 15. All right, so there's the outer geometry. Now we just have to come in and cut this. This is countersunk, so what we'll do is we'll say, so the inner hole is 30, this is 40, so it's 10 again. So offset this 5, and then offset it another 5. And then take this piece and move it vertically another 5, which will give me a 90-degree countersink. I could do that again on the bottom, or I could copy this geometry, flip it 180 degrees, and then move it right here, and then just pull this up to here, and done. That piece was fairly easy.
They've observed that his dog does the same thing where he cocks his head to the side while he's working on something.
I've grown out of doing this when I try to do hard applications, so tongue stays in the mouth. I feel good about it. Head to one side works okay. All right, I'm gonna save that. Oops, what did I? Command S? Oh, what was I hitting? I was showing hidden. My shortcut for show hidden. I don't know. Option S? Control S? How did I do that? I don't know. Something was happening there. There's a thing going on. Okay, what time is it? Okay.
12:03. Half an hour into this one. 3 minutes into this one, right?
All right, so we're getting quicker. That's something. All right, file, import. What if I do all three of these in 2 to 2.5
Wait,
hours?
you're missing a hold up.
And whoop.
Yeah, there's still one hold to do. Yep, between the two.
Oh, back here.
Yep.
Okay.
So you're not getting quicker. It's sloppier, in fact.
That's. Was there a difference? All right. So I'm gonna outside the group. I'm just gonna put lines in for reference, which I guess is just me fighting using actual reference lines. I don't know. And then I come in here, 20 drill, so it's a 10 radius circle, and then pull that all the way down, and come out of here and get rid of those lines. All right, now I can delete that and move this over into the done pile. Whew. All right, I think this next one's gonna be quick, he says, as the future chuckled at him. All right, file, import. This is a drawing, kind of looks like it's like a cam bolt or something like that. Is that the term you'd use for this thing? I don't know.
Sort of.
Robot head, maybe?
That's all I'm seeing is robot head.
Yeah, that's probably the accurate term. All right, so what I would do with this, there's a couple ways to go about this. I'm going to start with a follow me to get this overall shape.
Steve said you were still missing a box between the vertical and horizontal.
Oh, crap, I was. Undo. Okay. Right here. There is. He's right. 10 wide. Look in here. How wide is this? That's not quite 10. Okay. So right here in the middle, we'll go this way 5. Go this way 10. And then I will pull that up till it hits. Pull that up till it hits. I'm out of, oh no, that's, why you no break? There we go. And then how tall is that? Same height as this. Okay, so I'll just pull that up. Man, like I said, so much inferencing. And then I can pull this across till it hits the face. And then there will be some cleanup to do on the inside. So same thing, I can come over here, hide this bottom piece, and then just pop in here, and well, that wasn't too bad. Oh, here's another piece from the merger, the big merger. All right, there we go. Okay, edit, unhide all. I do want to say too, I do like the hide command for that short-term hiding individual pieces. If you're going to turn things on and off a lot, of course, you want to use tags to actually toggle things visibility. But hide is a nice, quick command to get something out of the way. Or a lot of times in a situation like that, I'll delete the face and then draw it back in later. In that case, it's harder to do because with all those holes, you end up having to repunch the holes out of the face, so hiding works a little better. Oh, no, what am I doing? Importing. Got distracted. Part 3. All right.
Can't mold a robot head.
That's right. That's the one. Hey, look, that's exactly what it says at the bottom. All right, let's draw this profile. So I'm going to draw half of this face. All right, so we go this way, 25. Wow, okay. This is way smaller than what's shown here. And then we're going to come up.
Minifig, Lego minifig.
That's right. All right, so it's going to come up 6.5. And then it's going to come back 3. Oh, so I see what's going on. So we got this thing where it's coming back 3. And then this 3. This is that. Yeah. Not quite square with that because it looks like it's a little off, but all right, so that's that. Yeah, so this should be 3.5 down from here to here. Yep. Let's just get you over here, pal. All right, so from there we go up another 3. This comes out to here, and then. All right, so now I need an overall height. So I'm going to grab this line. I'm going to move it, copy it up 50.
Wait, you've got a chamfer you got to do there again.
Yeah, but I got to get I'm just getting my overall dimensions in first, because then I come back and say.
Steve said it's a 60-degree angle, not 45.
Well, I was just going off dimensions, because the difference between these two dimensions is 6, which makes it 3 here. Yeah, and then, oh no, I assumed that. I assumed.
See what happens when you assume.
Yeah, I do. All right, so I'm going to take that, and I'm going to rotate it 60 degrees, which is absolutely right. It is half of 120 degrees, which is 60, and that is the line I actually want. So
what's the difference between 60 and 120 and 180?
Math. That's the difference. All right, I'm going to take this one and I'm going to rotate it along the middle of this 3 millimeter piece, and boom, like that. That gets me the mirrored chamfer right there. What's C2 mean? A chamfer of 2.
Sure.
Maybe.
Sounds plausible.
Or do I just take this right here and go C2? Oh no, that's 45 degrees of 2. So if I come right here, down 2, this way, 2, then that, I believe, is what that's showing.
Yep, that looks right.
All right, cool. So now I'm going to take that like this. I'm going to grab a circle. There we go. Come off. I don't have to actually have this connect to the bottom, so I'm just going to come back out like this. Doesn't matter how big that circle is. I'll grab it. Tools. Follow me. All right. That gets us the main portion of our minifig head. Let's get it upright so we All right. Now, we have lots of intersections to do with this piece. So I'm just going to take this, make it a group, verify it is in fact solid. Pretty simple. Follow me's, unless you have extra geometry floating around, are going to start off as solid. So that's pretty easy. Now, what we have is we have a chunk taken out of the front right here. We have these two chunks that are at an angle to the face or the front. And then we have two circles that go all the way through. So I'm going to make solids representing the pieces we want to take off, and then we'll just use solid tools to pull them away. All right, so first thing we have is something that is 30 tall. So I'm going to come over here. I'm just going to go, I don't know, draw a line like that. And I'm going to come up 30. Run this way. 30. Okay. That now, let's see. Find a hint on where this goes. Oh, it's 4 down from the top. So if I take this, bring it all the way up to the top, and now I move it down 4. This is at the right height now to cut in where it needs to. The question now is, how far in does it cut? Oh, right here, 18 off of the center. So if I come right here, let's do this off on the side, draw a line up here, 18. Now if I take this block, slide it in this way to that point, that is the volume I want to cut out. So if I take this, hit subtract from this, that gives me my little robot face. It also gives me a surface on which to draw these two circles.
That's very handy. Circles on circles is Trixie business.
It's very, very nice. Okay. These circles are 31 off of the bottom and then 10 off this. So I could take this line and option copy this way 10 and then copy back this way 20. And now I just have to find 31 off the bottom. And this is this is just generally what I do. I don't have a face that's necessarily in line with this, so I'm just going to draw a line over here, up 31. And now maybe I'll take draw a line across like that. There we go. Now I can grab these two and I can move them vertically to that. And now that gives me my circle locations, which are 8. So I can go a circle right here of 4, circle right here of 4. Get rid of all this extra stuff. So at this point, I'm just drawing outside. This is still a group. This is just raw geometry. So I can just grab that, pull that all the way through, double click, and then I can grab all of that, make it a group, and subtract it from the body. And we got eyes. I mean, holes for the cam thing.
We got eyes on robot.
Yeah, that's the thing. All right. Now, this part's going to be a little trickier. So what I'm going to have here, I'm going to draw another solid. This is going to be kind of 2 boxes that will then align with this piece. I'm going to draw them off on the side first because I'll get confused if I don't. So I'm going to draw a line. I'm going to draw a line over 44 and then draw another line down. And I'm just going to give this whole thing some geometry. All right. So the important part right now is this center. The center of this line is how we want to pick this thing up and move it. The fact that these 2 legs are different size doesn't really matter. What matters is that I now make it 15 tall. Do that. 1, 5, enter. I'm going to grab all of that, make it a group. All right. Now, I'm going to grab this and I'm going to align it with the edge. So you can see these are little, see, it's just going to shave a little chunk off right there is all. I'll go ahead and rotate it. Do I have a center point on the circle? Oh, it's not a circle, it's a follow me. I'll draw a line like that. And then I will rotate it 15. Again, I know I broken record here, but this is one of the nice things about using a 24-sided circle is I've been doing it so long that as soon as I see a circle like that, I look at it and I'm like, okay, based on this is the top, this is the bottom, this is the left corner, this is the right corner, and it's real easy to snap to those points. You always have the same number of chunks. If that was a 32-sided circle, I'd have to maybe slow down a little bit and make sure I was snapping the right one. It was 96. It's very difficult to get the right one quickly. All right, so now I need to push this to the right spot. It's the 10 down from the top to the top here. So I'll go ahead and grab this, move it vertically to here, and then move it down another 10. And now, as long as this isn't touching here, I should be able to take this and subtract from there. And there we go.
And so that if you use Interroth's auto will, it leaves you with circles after using follow me and shapes.
Ooh, I like that. Yeah, that is a good one that I haven't. Wait a minute.
Backwards. Went the wrong way.
I rotated it the wrong way. All right. So that means, need my line back. Why would they do that? Why would they show me this face?
It's backwards anyway. I mean, it's looking.
Yeah, this face is over. Oh man, they had no respect for robot line of sight. All right, so we rotated this way 30 degrees, right? Because we were 15 off. Yeah. Okay, there we go. Let's try this again. Get rid of that. Subtract from here. Wait. Subtract from here. There we go. There's that little sliver right there is right here. And if it looks straight on, you can just see the indent over here. Perfect.
Nailed it.
That's a fun little thingy. And I think this one, yeah, studycadcam.com. If you guys are looking for some sample files, these are good ones. They generally, I mean, I found that there's not many of these that are perfect, but StudyCAD-CAM has a ton. There's so many models there, and most of them are pretty good as far as the information on there. Every once in a while there'll be a missing dimension, but I always kind of see that as part of the practice, part of the challenge. All right, see if I can do this next one in like 10 minutes. We have some time to do the assembly. The assembly is the last one. It's actually made up of like 6 or 8 different pieces that all go together. So I'm excited about that one. All right, so I'm gonna go ahead and import another drawing. This is our part 4. This is the one that's may look a little like a logo of something.
Or MC Escher.
That's right. Staircase designed by an architect named Escher. All right. Very few dimensions on this one, which I think is kind of cool.
So it's not like left to right or top to bottom symmetrical, but it is 3 unique pieces. So all you really have to do is make.
Yeah, I should be able to make this one piece and use it in repetition. Let's do it. Let's start with this piece, and then we'll kind of work. It should build itself out from there. I don't know. I'm making stuff up. Let's see what happens. So we got a 60 by 60. I'm gonna start with a rectangle. All right, so if that is this face. Outside radius is 20. So if I come here and just draw an arc right here, I can select that and say, I want that to be 20. It'll go to the right distance there. It's 10, so if I grab that, this, and this, offset that 10, that gives me this piece right here. Then I also have, I feel like I don't have enough information here, but we'll work it out. So I also take, I'll start by taking these. offset these 10 also. And now I feel like, so this connects back up, and then these get smaller. I feel like this shortens up by another 10. And then that is, I'm assuming, 10 deep. I'm going to go ahead and soften smooth that. And I'm going to grab that and make it a component. Okay, so that is what I've done. Now to take that, so let's say that's this piece right here. Assuming my dimensions are right, and that was 10 and 10, that means that I have, if I was to draw a line 20 this way, and then 20 this way, that this next piece would sit right here. That would give me this angle here. Then we do the same thing here. I could go up 20 and go this way 20. And then I could grab this, put it right here, and then rotate that like that.
So you did this thing in 3 minutes.
Well,
Yeah.
I'm still assuming, so.
Well, Dave thinks you've got a good, calibrated, good eye.
All right, I'll take that. All right, and I'll grab this side, and this side. No, stop clicking. Ever do that? Ever just get clicky?
Yeah, I started double clicking and it turns out it's actually a quad click. For me,
I don't know what just happened.
autosave, auto close.
Wow, was it? I hit the auto close shortcut key.
Good thing it only took 3 minutes because you get to do it again.
Yeah, I don't know where that went. Excuse me.
We call it a crash.
I think that's fair. Wow. I guess it's good that I saved right then. Made me choke. All right, let's fly through that one more time. Excuse me. All right. Okay, so got a rectangle. Uh, 60, 60. An arc on here that is 20. I'm going to put it in and then set it to 20. And I'll just take the whole thing and offset it by 10. And then here we'll go up 10. And here we'll go this way 10. Pull that up 10. Soften and smooth that. I'll rotate that up. All right, so again, 20, 20. Grab this guy. So I was thinking about this too. I could take this. There's always multiple ways to do this. Option rotate, but then I do have to move it over like that, which I guess probably it's 2 steps either way, so I don't know if it makes a big difference. Let's come up 20, come over 20, do the same thing. I'll rotate it. Option rotate a copy, drop that down like that.
All right, save before you do the next part.
Command S. Whoa. Oh, it's because I'm in a race. Things are happening. All right. Now, let's get these back pieces on here. So again, I'm going to rectangle from here to here. I'm going to grab this side and this side, offset it, 10. Erase this and this. Push pull this, 10. All right, so now again, let's see if I can, if I draw a line middle to middle there, I should be able to rotate a copy 90 degrees. No, that doesn't work right either. That was further off. That was wrong.
This gets you in the right orientation.
It's something, yeah. If I go from inside to inside, let's see what happens on this one. That's way further off. That was not the correct command. All right, put that there. All right, last step then, now that I got those pieces in there, I got the look, I can grab all these, save, bring up my solid tools and give me an outer shell. And there we go. That was a fun little exercise right there.
Twice.
Yeah. I think I learned something there. It's always easier the second time. Awesome. All right, cool. Assembly time. This is the one I've been most excited for. We did, so one of the earlier machine parts, actually the thing that kicked off the machine parts was I found some drawings online of miniature steam engines, like things you could machine them yourselves from brass and copper and use copper pipe and that kind of stuff. Really cool little drawings. And we did that on a live model where we actually took those full drawings and modeled from scratch, which was really cool. But it's kind of what got this process started, is finding more of those drawings and kind of like quicker, easier ones. That was actually, I don't think the first one we did a steam engine, I don't think I finished it on air. I think I ran out of time after a couple hours. I had a few pieces missing, but it was a very cool one.
I thought we did. I thought you got it.
Maybe. I think we've done two. We may have done two. Dave probably knows, because Dave was probably modeling them as I was and getting them done quicker and having them look nicer.
Dave finished.
Yeah, I'm sure he did. I think I ended up finishing it eventually. I just don't know if I finished it whilst live broadcasting. All right. So here's what we got. So these are the pieces. 1, 2, 3, 4, 5, 6, 7 pieces all go together to make this one
Two of the
thing.
pieces are the same. So sweet.
We do, yes. So actually, yeah, the ends are going to be the same one, the component reversed. These little bushings will be the same. So it actually we only have 1, 2, 3, 4, 5. Oh, we're going home early today. All right. All right. Let's see if I can make this take as long as possible. No, I'm just kidding. All right. So here in this particular one, it will be a rare situation where I probably will use rectangle to start, because I have my dimension 72 by 120 right here. So I'll just grab rectangle. 72, 120. There we go.
It's really the radius, adding the corners, the curvy corners and things, is what slows the whole process down.
It does, and it depends on the geometry we're working on, where it's getting put in, because that definitely, yeah, it can be time consuming to get them in there right. It's nice when it's a situation like this, because I can come in, this is a radius of 12, so as long as I draw something that's on the magenta inference, like that, I can come back and select it and just tell it to, ooh, sometimes.
Oops.
So close to 12.
I didn't hear what you said, but both Bill and Andy said famous last words.
I could change it to 12. It was very close to 12. I almost eyeballed 12 on accident. And then I can just double click to place that. Place that. All right. With that, let's go ahead and we'll push that. Oh, actually, I'm gonna put my circles, my holes in here first. that 12? 12 drill?
It's neat how they made the font all hard to read.
Yeah, they angled the font too, which is I respect, but I can't read that. Oh, where's Colin with his photo optimization? Enhance. All right, so this 3.
Looks like it says 12 again.
All right, I'm just gonna grab both of these and bring them down from the corner option down to the corner. Delete, 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 delete. All right, I do that first because that now, if I had done that afterwards, I would have had to push pull each one down too. What's quicker, what's easier, deleting those beforehand or push pulling afterwards?
Should have welded the perimeter before you put pulling down.
That is true. He speaks the truth. That's what I should have did.
Three. That number's 3. I can tell from here.
Yeah, I'm just trying to find out how wide it is though. Because it looks, oh, right there. So 23 off the bottom of the circle. See, this is the part that I find, this is the fun stuff right here is, you know, trying to figure out where dimensions at. Oh man, hold on. I'll show you guys what to do with that in a second. In this case, I'm going to grab these 2 lines. Just pull it over like that. Oh, made a bigger mess over there. I was trying to save myself work. Not what I did. Let's see if I go like this. That comes back. Do this one. That one came back. So for whatever reason, well, actually it may now because I redrew the face by drawing the last one in. I'd say every once in a while you get a hole like that and it won't heal itself. What I will do in that situation, so if this guy, I couldn't get this to come apart, rather than deleting the whole thing and starting over, I'll isolate the hole. So I'll do something like this. Now that puts that hole onto a separate face than the rest of it. And sometimes just doing that will fix it. So if you ever have a situation like that where you have geometry that's in plane, but for whatever reason it's not cutting, doing something like this, putting a little line around it forces it to recalculate what that face is, and sometimes will fix the problem right away. In case that ever happens. All right, that goes up 3. On this side though, oh, did I have some clean up? Clean up. All right, on this side, this piece, oh, I did that wrong. The top is at 23. I think that, is that supposed to be lined up?
I mean,
Here, let's,
on the back edge, it looks like it is, but on the front, yeah.
it's one of those, what do you call them, optical delusions. All right.
The lack of any kind of measurement suggesting otherwise.
It's gonna win, yeah. All right, so we'll pull that up. Another blurry 3. All right. So make the component. I'm gonna call it the base. All right. The piece on which all other pieces shall be built. All right, so here's the question. Can I save myself a little bit of work here? Can I cut a corner? Can I copy this? Bring this over here.
I think you can.
Is this 35? Oh, it is. And is the center of circle 48? Ooh, wait, there, 48. Oh, look at that.
And it's R12, which would make sense. Those pieces go together.
It does make a lot of sense. I guess I'm not used to things working that well or easy. There's still plenty of time to screw it up though, guys. Don't worry. All right, I'm gonna take that then, and I think this is a 6. So I'm gonna pull this up 6. Oh, hey, I'm gonna use Jody's advice. Undo. I'm gonna grab this line and this arc, and this line and this arc and this line. And I'm going to weld them. And then I'm going to pull this up 6. Ooh, look at that.
Well,
Good
could be its
stuff.
own exclamation like sadist.
Weld. We'll bring that in 5. Then my overall height, I almost have to back it up so I can like, up close it's even harder to see, is 10. So this comes up another 4. There's my base. Save. All right, so I got my holes in there. What is this width? 8. So I'm going to grab this line, option copied over 8. Now I got to draw this profile here. So I'm going to go from the center. I'm going to go up 50. I feel like if I take this whole thing and rotate it, does that look closer than, I don't know. Anyhow, trying to cut corners where I probably don't need to right now. All right, anyhow, focus. All right, so I have 2 radius of 15, and this is a hole of 12. So I'm going to start with my outer circle. I'm going to come over here.
Why not model the bracket in place on top of the base?
Because the base is all the way over on the other side of the shop right now. Okay, that's a good point, Dave. Let's bring this over here. All right, I'll grab all of that. Move it right on top. All right. Now, I'm going to take a line straight down, line straight down. That's that outside section. Now, so before I kind of drew an arbitrary arc and then used.
Wait. You should undo that circle so you can pull your circle out a little bit.
Ooh.
You need to extrude that in an
You are correct. Let's keep that. All right. So last time I drew an arc, I drew an arbitrary amount, which was very close to what it was supposed to be, but then use empty info. I don't have to do it that way. I know this is that a 5 or a 3? A 15 or 13?
That looks like a 15.
Okay, we'll call it 15. So what I could do is I can come in here, draw a line this way, 15, draw a line this way, 15, and then I can connect that together with an arc. I'll take that arc and I will rotate it from the middle of this column, option, like that. And then we push that out to here, push that out to here, and then pull it out an additional 13, so that's 5. All right, and doing that, this is not totally unexpected to have this happen this way. I can't say why, but when you start doing push-pulls on existing geometry, this can happen. Usually it's not a big deal. If you don't have a lot of interior geometry, it's usually as simple as right-clicking on a correctly oriented face and saying orient faces to get everything pointing the same way again. Yeah, so it happens. All right, there we go, there we go, there we go. All right, so now we have a brace right here, and we have a hole in the middle. So I'll start with that hole in the middle. Start here.
No chamfers or curves on the brace.
That's right.
Excellent.
Just straightforward triangular brace the way we like them. I think it's going to be as simple as going here, up 40, back down to the center point here, back to here, and we pull it this way 5, and then we pull this one this way 5, and then orient faces again. Let's see if that ends up. Oop, oh, hold up. I'll make that component. bracket, as the plans say. All right, so when I did that, you see it did not come through as a solid component, but just as a component. I am guessing that probably when I put this piece in here, maybe it didn't get rid of all the geometry on the inside. So obviously I could use Solid Inspector to look at it, but if I don't have Solid Inspector, don't want it for whatever reason, it's probably an easy enough cleanup. I'm going to double click to come in here and I'm going to hide the rest of the model. So I'm isolating my view, so I'm only seeing what's inside the selected component. And then I'm going to do the same thing as I did before. I'm going to hide this one piece, come peek inside. Sure enough, there's my problem. That geometry shouldn't be there. Delete it, edit, unhide all. And now if we pick on it, now it is solid. All right, let's do one last thing here. Grab that, rotate it from the center, option copy, and save. Are you saving? All right, there we go. Cool.
Save times 3.
All right, that's right. It is so saved for real. All right. Okay, so now we got 3 more pieces to put on here. 3 more pieces to model. 4 more pieces in total. Let's start with the shaft right here. So there's a couple ways we could do all of these pieces. I feel like doing push-pull is going to be the easiest for the shaft. Maybe we'll do the roller as a follow me. We'll see. So in this case, what I would do, and there, again, I say it that way because there's so many ways to do any of these things. I would probably start with a circle that is the outermost dimension. So that is 18. So I'm going to draw a circle with a 9 radius, and then I'm going to make that 50 long. All right. Now up here, this is going from 18 to 12. So I'm going to offset half that distance, which is half that difference, which is 3. All right, now I'm going to pull that out 15. And now I have a 2x45 chamfer. So here's what I'm going to do for that.
Dave said to draw the shaft in place between the brackets.
Come on with your in-place stuff. I can't see it as well there. It's in the way. I'm going to offset this 2. I'm going to take the outer ring and then move it vertically to give me that 2x2 chamfer. So if I was skeptical and wanted to verify, I could come over and draw that over 2, down 2, and I could actually check and see that that's exactly what it was. The other thing I could do there is I could do a subtractive follow me, where I could actually go on the inside and draw that same angle and do a follow me all the way around to cut it. But grabbing the ring and just pushing it down if it's the same amount is pretty simple. Then it has a 6 drill, 45 deep. So we'll go circle, come to the middle, 3, and I'll push that down, 45. Now we're getting close here. I'm gonna take this and move it off the paper, like it's something. I'm gonna grab all of this. I'm gonna draw a line. Actually, I don't need a line. Watch this. I can just turn on my hidden geometry. And I take all of this and come to the middle point right here.
Yeah.
Now, here's my question. Here's the thing I'm not getting from this. So this hole, is that only on one side? Oh, is that like for oiling or something? Because it doesn't look like it's actually on the other side. So is
You can't really tell.
this what this thing looks like? Is it like that? And then,
I mean, what would the oil be accomplishing by putting it in the middle of the shaft like that? There's nothing going through it.
was this a stationary shaft and these spin on?
It's the bushings.
It's only, Dave said it's only one end, so that's really all I am concerned about. So I'm gonna grab this. Oh, something didn't quite join up. I know that copying that like that will create some extra geometry on here too. So I might do the same thing where I'd hide this piece. There we go. Okay, this is almost done, except I need this one last hole. So there's another number 6 hole. The line's going like this, so I'm assuming it goes all the way through, 25 down from the end. I'm gonna go C. All right, and rather than doing solid tools, I'm doing this one a little bit differently. I'm gonna pull that all the way through like that. I'm gonna select and reverse the face of this tube on the outside. Here are these faces so you can see. I'm gonna select these 2 faces and probably this guy right here. And then right click, intersect with selection. Now I'll delete that, delete that, delete that, delete that, delete that, and delete that. Actually, I probably have a couple more to delete here. All right, there we go. And that's what that looks like. 2 overlapping drilled holes through there. I could have done that. I could have actually made the main shaft a component a little bit earlier and then use subtract to do that, but you know, we're here to learn. We're here to experiment. All right, triple click that, make component. Is it actually called the shaft? Is that? Yeah.
It is.
Boom, shafted it. That's not the proper use of that term. All right, so now I can take that, I think, and grab it by this, and this should line up pretty, oh. Huh.
After 24 faces don't quite line up.
How many are these on this one?
I think it's just that you need to rotate it just a skosh. Your peaks and valleys are perfectly smashed. Yeah, there you go.
It's just slightly off there, see that? So let's do this. Put that there, and then we'll slide it over from, it's too close, I can't figure out where it is. All right, so that is that. Yeah, that's weird. Like, I kind of wonder if like the idea is you put a pin through something and then tighten the screw. I don't know. It's a hole. It's a hole. It's in the drawing. It's a hole. Who cares? Obviously, I care. This is me. I'm the one who cares. Okay, so I'm gonna draw the bushing first. I'm gonna do it the same way. I'm gonna draw a circle. There's obviously, like I keep saying, there's different ways to do this. With something this simple, where it's basically just a couple of stacked cylinders, it's probably more work to do a follow me to try to draw the profile than to do it this way.
Push pull, push pull, push pull.
Right, 12 is my outside, and then that's 3.
Should go ahead and save just in case.
Command S. And then I have a circle inside that. That's 24. So I'm just going to draw one 12. Then push pull that up, 21. And then my inside diameter is 18. So draw another circle right here. It is 9. And then pull that down to there. So I think it would have been,
You couldn't have done it any faster.
Right. Yeah, I don't think it was more or less efficient than doing it. Yeah. All right. Make component. Bushing. All right. This guy's going to go. Like that. And I'm going to spin him.
Oh, yeah, okay, so Bill said, like a bearing lubrication hole, and so if you put like a bearing or something in the hole that we can see from the top there, you lubricate it from the end.
That makes sense. All right. All we need now is a wheel. A roller, if you will, which is, of course, the way smart people say wheel. All right. With this, I think here's how. So I want to do this with Follow Me for no reason, I guess, other than I said I could. So it's not necessarily a good reason to do something, but I'm going to do it. I'm going to try it. All right.
That's the American way.
So here's what I would do. I would start probably with this rectangle here. So my overall outside dimension is 76. So if I was to draw a line 76 by 40. All right, so that's the profile of my roller. So I'm going to cut it in half because I only want to model half of this. All right, so 76, and then here I have 70, so that's half of that is 3. So I take this option, move that down 3. That gives me my outer ring. Right here at the center, 24 bore, so that means take this one, move it up 12. And then outside of that is 30, so that's 15, so that moves that up 3.
You're just doing all this math in your head.
Which means it's probably wrong.
That's true.
All right, so now I have some more dimensions here. So this outer piece right here is actually 7 in. So I'll take this one right here, option move the 7, and then I'll just take that whole rectangle and move it over here. So this is my inner wall, this is my outer wall, and now they do connect back together. So it's with a piece that's 8. So I'm gonna draw a line like this, and I can move it this way 4. And this way 8.
Exciting.
That doesn't look centered. Try that again. All right, option, read this way 4. Back this way 8. All right, so this, I'm gonna keep this line because that's the center. I don't want to delete that. But this is kind of how that roller works. I do have, there's some tapers in here. Is that saying it's 7 on one side and 9 on the other? Kind of looks that way, doesn't it?
I see 7 and 8 and 9.
So this is 7. 7 right here. Sorry. 7. Nope. 9. What the crap? Oh, it's in. That's the dimension in. Okay. Yep, we're good. 9. Everything lines up. Now we got some angles. So this one, 40 degrees down. If I draw a line like this, I take that line, and I rotate it. That can't be right. Oh, it's the dimension from the center is half of 40. Okay, so this is 20. This is for somebody who's turning this, obviously, makes sense. So that's this dimension. And then this says 66. So I would come up this way. 66. No, half of 66. So at the midpoint, there we go. 33. Get me that. Awesome. So got to get that over on the other side too. So grab 1, 2, 3.
These fingers numbers are diameters.
Yes.
It's good to be validated.
I think, so again, going back to, could we have drawn that with just a bunch of circles? I think the issue with drawing with a bunch of circles would be getting those exact dimensions. I think that would have been difficult.
Well, the fact that the instructions are for someone turning it on the lathe, and that's pretty much what Follow Me does.
It does make a lot of sense. All right, so I should be able to grab this circle. Follow me. Uh-oh. I don't have a face. There we go. Follow me. Make that into a component. Come on, man. And call that the roller. All right, grab that by the top. And slap it right here for right now, because I have a snap point there. And then from there, I can drag that over to the side. Oh, it's not center. What? Wait, what?
So it flows in the middle. Or the bushings.
At the bushing way. Okay, so how far apart are these guys? 2. So scoot them 1 millimeter.
Tolerances. It's all about
1.
tolerances.
Maybe. See if that does it. Let's slide this guy. Whoa! Like that? I can see why you wouldn't want your bushing necessarily rubbing up against this, but I feel like the gap's odd. But
so I feel like the bushings probably go all the way up to the edge. And then there's a bearing in the middle that helps kind of hold them sort of taut.
You'll notice there is not a fully assembled drawing. So maybe we caught some shenanigans.
It's entirely possible.
The important thing is we did a thing. But yeah, I mean, it does add up because look, the overall dimension here is 21 minus 3. So that's 18 and 18, and the outside here is 40, so those two won't touch. Wait.
Dave thinks the bushings are pressed into the roller. And it'll have a little room.
Yeah, so that's the way. Wait a minute. Hold on 1 second. Who's quality control on this? I did this wrong. I drew this 21, but the overall is 21. So this piece has to push back 3. Which makes a lot of sense because check this out for a second here.
Hear me out.
That's right. So if I do push that all the way in, which I buy that. I buy that. Now, if I hide this, look what this does. Look at that little space for the lubrication to get right in between there and lubricate whatever thing mechanical deal is happening.
Exactly.
Boom. So it does, yeah, floats a little bit here, which I want to think that maybe something's off there, but I mean, that would mean both the shaft and the base were incorrect. So I'm kind of having a hard time 2 millimeters on either side because this is, yeah. This is 40. Yeah, so
They said there is a fully assembled image on the web too, so I think he's checked and he's saying it's right.
you know, it's funny because this thing, there's probably a good 24 different drawings of this. So I think this is maybe something that maybe machinists practice building. Yeah, this is a commonly modeled or commonly built thing because this roller pulley thing, whatever, belt roller support, this plan was done over and over again that I found. But hey, that was number 5 of 5. That was, look how little it is compared. I figured since those pieces going together, it'd be bigger, but
You can put small pieces together.
apparently
Small
so.
things.
Does happen. But that's pretty cool. That turned out pretty neat. I like it.
Attaboy.
All right. Well, here, let's get rid of Sumelis. She doesn't trip on anything. And those are our pieces. I'm prepping for the thumbnail. Oh, you know what I should do? I should do what Tyson does. Tyson always does. He has the nicest looking thumbnails. Let's get a shadow turned on here. He does that a lot. A little extreme. Maybe we'll bring it back a little bit. Oh yeah, that's nice. That's good. Square it up a little bit. I think that's gonna work. Awesome. Well, there we go. Yeah, so I know there's a lot of comments coming in. I apologize. The text is really small on this screen. I have to figure out a way to make it bigger because I know people were saying things, but this is what I'd have to do to read the text. That's right. So thank you for whatever you guys were saying. Hopefully it was positive. That's good.
There was some German stuff on it and I couldn't read it.
Oh, that was probably insults. I'm fairly certain. Speaking code, if you're gonna talk bad about people, that's how I do it. Smart thinking. Yeah, so there we go. That is 4 machine parts and 1 assembly made of multiple machine parts. But yeah, a fun way. And like I said, if you're watching this later, you just came across this, this isn't necessarily the primary function of SketchUp. SketchUp's not necessarily perfect for creating machine parts. You send to CNC or something like that. It does create segmented circles. It creates line pieces. Everything's accurate, but it loses it in the arcs a little bit as far as accuracy. The real reason you would want to do this kind of work is to practice. So if you are newer to SketchUp or newer to 3D modeling, Googling machine part drawing will bring up tons of work that you can practice with. It's just a great way to get good and quick at modeling. You can model houses and that kind of stuff off of plans. That's great. But this is a way to sit down for like half an hour and really lunchtime, something like that, get some good SketchUp practice under your belt.
That was actually 2 hours.
Okay, do one of these at lunchtime. Yeah, not this many. I mean, hey, if you can do that, if you could do this many pieces an hour, you're probably doing pretty good. But yeah, that's what we got going. That is our show for today. I do want to point out that we have started selling tickets for 3D Basecamp 2022. So if you go to 3dbasecamp.sketchup.com right now, you can actually be one of the first to purchase a ticket to Basecamp and plan on joining us in Vancouver in September 2022 to hang out, talk about SketchUp, learn about SketchUp, have fun with some awesome people who you only get to see at this event, which is really cool. But yeah, it's a great time. And if you've ever been on the bubble about it, this is going to be a really, really good base camp. I mean, they're all good, but this is going to be the biggest base camp we've ever done. We're going to have more classes here. We're going to have more people here. This is going to be a great time. So if you're thinking about it, go check it out. There is early bird pricing right now. So I don't know how long it runs, but like all tickets to events, prices are just going to go up over time. So check it out. Join us there. I'll be there. Dave's going to be there. Jody's going to be there. I don't know what else you guys would want besides that. That pretty much.
Tyson will be there.
So it's still worth coming though. I cut Jody off. I knew he was going to say something.
I was just going to say Matt's going to be there too. But I didn't want to exclude that.
That's true. Yeah. So all of the live group will be there. People you've seen on Fireside Chat, that kind of thing. And then of course we're bringing in, it's always fun. I hope for you guys to see us learn SketchUp, the training people, Tyson, myself, showing you guys how you SketchUp. The nice thing about Basecamp, if you haven't been there before, is most of the classes are taught by practicing professionals. So it's not just academic, it's actually practical, a lot of the content that's taught. So people who are professional designers, architects, that sort of thing will come up and actually be doing a lot of the classes. It's really cool. Great way to learn SketchUp, whether you're beginner or advanced. So check that out, 3dbasecamp.sketchup.com, and hopefully you'll join us there. But that's going to be it for this week. So we will say goodbye. Tyson will be back in here next week doing something. We keep talking about planning things ahead of time, but we keep not doing that. So we'll figure out what that is. And of course, we'll put it up on our forum, forums.sketchup.com, or watch our social media, and we'll tell you what's happening. But it will be back here 1 week from today at noon Mountain Time. So till next time, we will just see you guys later.
See you guys.
Thank you.